When food is consumed, the body shifts into a fed state marked by several key changes in blood chemistry and hormones. Blood glucose, or blood sugar, rises depending on the type of food eaten. Simple sugars like sucrose, glucose, and fructose drive a rapid and steep increase, while complex carbohydrates such as bread or pasta raise blood glucose more moderately. Fibrous carbohydrates like lettuce or broccoli have very little effect. Protein produces a modest rise, and fats produce the lowest increase of all. Along with this increase in glucose comes a rise in insulin, the hormone that moves glucose from the bloodstream into tissues for immediate use or storage. This combination of elevated glucose and insulin sets the body into storage mode, prioritizing growth and energy availability. The exact response varies across individuals depending on metabolic health, insulin sensitivity, and recent meal history. For some people, a carbohydrate-rich meal will cause a sharper rise and longer elevation of insulin and glucose than for others. These elevations are not momentary. Even after the last bite, it takes hours for levels to decline back toward baseline. The body remains in this fed state until glucose and insulin fall, meaning digestion and metabolism extend far beyond the actual act of eating. When no food is consumed for long enough, the body transitions into the fasted state. In this state, blood glucose and insulin fall, and other hormones begin to rise. Glucagon increases, signaling the body to mobilize stored energy. This process, called lipolysis, draws on fat reserves, but can also use carbohydrates. And in longer fasts, even muscle as energy. Hormones like GLP-1 also play a role, influencing appetite and glucose regulation during fasting. In simple terms, the fed state supports growth, while the fasted state supports repair. The transition between these two modes is not instantaneous. A meal eaten in the evening, for example, can keep glucose and insulin elevated for several hours into the night, delaying the onset of true fasting. This delay is critical because many of the health benefits associated with fasting occur only after glucose and insulin have remained low for long enough. Processes such as autophagy, in which damaged or dysfunctional cells are cleared away, are heightened during fasting, but blunted when glucose and insulin are continually elevated. From the perspective of metabolism, eating and fasting set very different conditions in the body. Eating promotes cellular growth and nutrient storage, while fasting shifts the system toward energy mobilization and cellular repair. These cycles influence not only energy balance and fat loss, but also broader health factors such as hormone regulation, inflammation, and tissue recovery. In the fed state, the body is biased toward growth, but in the fasted state, the system turns toward repair and renewal. Both are necessary, but they must occur in balance. This interplay explains why the duration of eating and fasting matters as much as the content of food itself. Prolonged feeding windows that stretch across much of the day keep glucose and insulin elevated for too long, minimizing time spent in repair mode. By contrast, allowing longer fasting periods creates windows where fat stores can be used and where the body can engage in processes essential for long-term health. A simple way to think about it is this. Eating is not just about providing fuel. It is also about setting the body into a particular biological state. Fasting is not just about withholding food. It is about shifting into a different state altogether. The timing of these states, when they start, how long they last, and how consistently they are repeated, is what ultimately shapes health outcomes. Calories are often described as the main determinant of weight loss or gain, but the way the body handles calories depends heavily on hormones and metabolism. Two people can eat the same number of calories and yet experience very different outcomes. Not because the laws of thermodynamics don't apply, but because what is happening inside their bodies changes how much energy is used, stored, or wasted. Research comparing different diets shows this clearly. When people are assigned to a low-carbohydrate or a low-fat diet, some lose a great deal of weight, while others lose very little, even when total calories are similar. At first glance, this seems confusing, but it highlights that calories in versus calories out is not just about food consumed and exercise performed. It is also about what happens between those two ends of the equation. the efficiency with which the body extracts, stores, and burns energy. Hormones play a central role here. Insulin, for example, is not only responsible for moving glucose into cells, but also for determining whether that energy gets stored as fat. Someone with higher insulin sensitivity will process carbohydrates more effectively and may feel more energetic, while someone with insulin resistance may store more of that energy as fat. Thyroid hormones also influence the speed of metabolism, dictating how many calories are burned at rest. Sex hormones like testosterone and estrogen affect muscle mass, which in turn alters resting energy expenditure. Even subtle shifts in these hormones can change how the body manages calories. Another factor is spontaneous activity, sometimes referred to as non-exercise activity, thermogenesis. This includes all the small, often unconscious movements such as fidgeting, shifting posture, or walking around during daily tasks. These activities can burn a surprising number of calories over time, and their intensity varies greatly from person to person. Someone may overeat by several hundred calories, but unconsciously offset much of it by moving more throughout the day, while another person may sit still and store that excess as fat. What this means in practice is that counting calories is not always a reliable predictor of weight change. The same meal can produce different metabolic effects depending on the individual's hormonal state, body composition, and activity patterns. This explains why some people on carefully measured diets fail to lose weight, while others eating freely still manage to lean out. The body is not a static machine. It is a dynamic system, constantly adjusting to signals from hormones, food quality, and energy needs. Beyond weight, the way calories interact with hormones influences overall health. Frequent large spikes in glucose and insulin can increase fat storage and reduce sensitivity to insulin over time, raising the risk of metabolic disorders. In contrast, stable glucose and insulin levels, supported by food choices and fasting intervals, encourage the body to use energy more flexibly, alternating between carbohydrates and fat. This metabolic flexibility not only supports fat loss, but also improves long-term resilience. So while calories matter, they are only part of the picture. The body does not simply tally numbers. It interprets them through a web of hormonal signals and energy pathways. Understanding this helps explain why time-restricted eating and fasting can have such strong effects. By influencing when calories interact with hormones, they shift the way the body manages energy, often without requiring conscious calorie counting. Experiments on meal timing have revealed that the body responds not only to what is eaten, but also to when it is eaten. In studies with animals, two groups are given the exact same type and amount of food. Yet, the outcomes are dramatically different depending on whether the food is available all day or restricted to a specific window of time. Those allowed to eat at any hour tend to gain weight, accumulate fat in the liver, and develop metabolic problems. Even though their calorie intake is identical to the restricted group, those confined to a daily eating window remain leaner, healthier, and show better liver and metabolic function despite eating the same number of calories. The reason for this lies in circadian rhythms. Nearly every cell in the body contains genes that operate on a roughly 24-hour cycle, turning on and off in coordination with light, exposure, activity, and feeding. About 80% of these genes are influenced by when food is consumed. If eating is spread throughout the day and night, these rhythms become blurred, and processes that are supposed to be active at certain times lose their sync. When feeding is restricted to a consistent window, these genetic rhythms become anchored, and the body's internal clocks operate more efficiently. In practical terms, this means that the timing of meals can amplify or blunt the effects of diet. Eating within a fixed window of time supports the natural cycles of hormone release, metabolism, and cellular repair. This allows the body to spend part of the day in a fed state and part in a fasted state, aligning with its natural design. Extending eating across many hours leaves little opportunity for true fasting and repair. Keeping glucose and insulin elevated for too long and limiting the periods when fat and cellular cleanup processes can take over. The concept of time-restricted feeding is therefore less about reducing calories and more about giving the body predictable patterns of intake and absence. Even without deliberate calorie reduction, individuals often lose weight and improve markers of metabolic health simply by shortening the daily eating window. This is because energy, regulation, hormone balance, and circadian biology are being aligned rather than pulled in competing directions. Regularity is just as important as duration. Choosing an 8-hour eating window, but shifting it unpredictably each day prevents the body from fully adjusting its internal clocks. A consistent schedule, whether late morning to early evening or noon to night, allows the circadian system to anticipate feeding and fasting phases, optimizing hormone release and nutrient processing. The alignment of meal timing with circadian rhythms also influences other aspects of health, including sleep quality, gut microbiome, balance, and even cognitive function. The microbiome in particular follows its own daily cycle, responding to feeding patterns. Consistent eating windows promote a more resilient and diverse microbial community, while erratic or prolonged feeding can disrupt it, leading to inflammation and impaired gut health. The main lesson is that food is not simply fuel, but also a signal. The body interprets eating times as cues to synchronize internal processes. By restricting meals to a daily window and maintaining that pattern consistently, the body can operate in harmony with its natural cycles, leading to better weight management, improved metabolic function, and greater overall health. A daily eating window shapes the way the body handles energy, and several simple rules make this practice especially effective. One useful guideline is to avoid eating for at least an hour after waking. During the early part of the day, cortisol is naturally elevated, helping the body mobilize energy and become alert. Eating immediately in this state can create an unnecessary spike in glucose and insulin, reducing the natural benefits of that early rise in alertness. Waiting an hour or more allows hormones to balance and makes the first meal less likely to produce large fluctuations in energy. Another important rule is to avoid eating in the final hours before sleep. Digestion continues long after the last bite, and if food is consumed right before bedtime, glucose and insulin remain elevated into the night. This not only interferes with fat burning, but also disrupts processes of cellular repair that are heightened during sleep. Allowing 2 to 3 hours between the last meal and going to bed ensures that the body can shift into a fasting state overnight, supporting both metabolic health and sleep quality. The length of the feeding window matters as well. Research consistently points to about 8 hours as a sweet spot for most people. Within this range, glucose and insulin rise during the day when food is consumed, but are given enough time to fall to low levels for the rest of the day and night. This creates a balance between growth and repair, allowing fat burning and autophagy to occur without excessive calorie restriction. Common windows are from noon to 8 p.m. or 10 a.m. to 6 p.m., but the exact hours matter less than the consistency. Maintaining a regular schedule is critical. The body's internal clocks adjust to the timing of food, and if the eating window shifts daily, those clocks never stabilize. A window of 12 to 8 p.m. one day and 9 to 5 p.m. the next prevents the circadian system from predicting when to expect nutrients. Consistency allows hormone release, digestive processes, and cellular rhythms to align with feeding, maximizing efficiency. These rules create boundaries that naturally reinforce both metabolic and circadian health. Delaying the first meal supports natural hormonal rhythms in the morning, closing the window before bedtime supports nighttime repair and sleep, and keeping the total window at about 8 hours creates enough fasting time for fat burning and cellular renewal. Together, they form a practical framework for aligning eating with biology, often leading to weight loss, improved energy, and better health even without conscious calorie counting. Restricting food intake to a daily window produces benefits that go well beyond weight management. One of the most striking effects is on the liver. The liver plays a central role in processing nutrients, regulating blood sugar, and detoxifying the body. When feeding extends across many hours, the liver is continually engaged in processing glucose and fat, which can eventually lead to fat buildup and impaired function. By narrowing the eating window, the liver gets extended periods of rest, during which it can clear out fat and repair itself? Studies have shown that even without reducing total calories, time-restricted feeding reduces liver fat and improves liver health. The gut microbiome also responds strongly to eating patterns. The trillions of microorganisms that live in the digestive tract follow their own circadian rhythms, flourishing and retreating in daily cycles. When food is available around the clock, these cycles are disrupted, leading to reduced microbial diversity and increased inflammation. Restricting meals to a consistent daily window allows the microbiome to anticipate feeding times, strengthening its rhythm and enhancing its resilience. This shift promotes better digestion, stronger immune function, and improved overall health. Another major benefit is reduced inflammation. Chronic low-grade inflammation is linked to conditions such as heart disease, diabetes, and neurodivergence. By extending the fasting period, inflammatory pathways are dialed down and anti-inflammatory processes are enhanced. Part of this comes from reductions in glucose and insulin, which when constantly elevated can drive inflammation. Part also comes from cellular repair processes that are heightened in the fasted state, removing damaged components that would otherwise provoke inflammatory responses. The brain also benefits from time-restricted feeding. Fasting periods increase the release of molecules that support learning, memory, and resilience to stress. At the same time, blood sugar becomes more stable, preventing the sharp rises and crashes that can interfere with mood and concentration. Many people report improved clarity and energy when they adopt a consistent eating window, reflecting the brain's ability to operate more smoothly when energy regulation is stable. These benefits combine to create a wide-ranging impact on health. Improved liver function, a healthier microbiome, reduced inflammation, and sharper cognition all emerge not from changing what is eaten, but from changing when it is eaten. The body thrives on rhythm, and providing predictable periods of feeding and fasting gives it the structure it needs to maintain balance and repair itself. The effects of fasting and time-restricted eating are not identical for everyone. Differences in genetics, hormone levels, age, and lifestyle all shape how the body responds. Some people notice rapid improvements in weight and energy when they adopt an 8-hour eating window, while others experience slower or more subtle changes. In women, fluctuations in estrogen and progesterone across the menstrual cycle can alter appetite, glucose regulation, and insulin sensitivity, sometimes making fasting feel easier at certain points in the cycle and harder at others. Men, with generally higher levels of testosterone and muscle mass, may experience different effects on energy expenditure and fat use. The gut microbiome also varies widely between individuals, and this variation influences how fasting affects digestion, metabolism, and inflammation. Still, a consistent pattern emerges across many studies. When people restrict their feeding to a daily window, the diversity of gut microbes improves, harmful bacteria decline, and protective bacteria thrive. This shift strengthens the gut lining, reduces inflammation, and supports metabolic flexibility. Even modest changes, like moving from a 12-hour eating window to a 10-hour one, can begin to produce these microbiome benefits. Transitioning into time-restricted eating can feel challenging at first. The body is accustomed to receiving food at certain times, and hunger signals follow those patterns. During the first several days of narrowing the eating window, people may feel increased hunger or cravings as hormones and digestion adjust. These sensations usually diminish within a week to 10 days, once the body adapts to using stored energy more efficiently during the fasting period. Small adjustments, such as gradually delaying the first meal or ending the last meal earlier in the evening, can ease the transition. An eating window of about 8 hours appears to provide the strongest balance between feeding and fasting. But shorter windows are not necessarily better for everyone. Some may thrive on 6 hours, while others function best at 9 or 10. The key is to maintain a schedule that is sustainable and consistent. Since regularity reinforces the circadian rhythms that underlie many of the benefits, by contrast, frequently changing the timing of the window or extending it late into the night diminishes those benefits. The long-term impact of time-restricted eating goes beyond body weight. Many people experience improvements in energy, focus, and sleep. Markers of metabolic health, such as fasting glucose, insulin sensitivity, and blood pressure, often improve, even when total calorie intake remains the same. These shifts suggest that when food is consumed may be as important as what is consumed, because timing influences the hormonal and genetic programs that regulate energy and repair. Over time, adopting a regular eating window becomes less about dieting and more about aligning lifestyle with biology. Instead of constantly battling hunger or counting calories, individuals allow the body to follow its natural cycles of growth during feeding and repair during fasting. This balance not only supports fat loss, but also strengthens resilience, reduces disease risk, and promotes a healthier relationship with food.